Okay, I'm wondering, did any of you have trouble with multiple choice number 3? It says the final score of a soccer game is 6-3. How many ways could the score have been at halftime? If you haven't tried that, you need to try it because it's a tricky one. Let me know if you have questions. Just note it, I'm pointing that out to you because I think a lot of people kind of skip over questions and don't think they need extra help, don't need to do every question. There's an example of why you need to work right till the end of the homework assignment. Okay, try it. Let me know if you need help. Okay, so yesterday we talked about the arrangements of a set of objects. We're going to specifically focus on the permutation, where the idea that order matters is key. Really, everything we did yesterday was a permutation, but let's emphasize that a little bit more today. So most of these questions we should know how to do with the skills we had. How many ways can the letters in the word math be rearranged? Well, there's 4 letters. How many can go in the first spot? 4, and then there's 3 in the second, 2, and 1. Pure and simple, this is called a permutation. Okay, it's taking a number of objects, arranging them in different ways, and telling you how many ways can you do that. Okay, if we do counted, there are 7. So again, we'll think about 7 spaces here, and it's pretty straightforward. It almost becomes redundant, and you start thinking to yourself, hey, maybe shouldn't there be a shortcut for how to do this? Okay, let's see. What is 7 times 6 times 5 times 4 times 3 times 2? Okay, 5,040. All right, well, there is a shortcut. Rather than write out this big, long arrangement of numbers, we can use something called factorial notation. Okay, it can be used to simplify the steps. Now, factorial sign is just the exclamation mark. So if we take n objects and say factorial, this doesn't mean you're supposed to yell it. It doesn't mean n. It means n factorial. And what it means is you take the first number, whatever n is, and multiply it by 1 less, times 1 less, times 1 less, all the way down to 1. Okay, so for example, if we looked over here, another way to write this is 7 factorial. Okay, and now usually I would get you to get your calculators out and find the button, the factorial button. But I can't help you today. You're going to have to find where it is. Okay, there will be a button that is factorial, the exclamation mark. So you're going to have to find it. We'll practice a couple in a second. You should take some time to figure out where it is on your calculator. By the way, here's something that you haven't seen before. This idea of something where by definition, so we're saying that 0 factorial is equal to 1. Now in your head, if you're using this notation, this would mean 0 times 1 less than 0 all the way down to 1. Well, if you multiply this, this should equal 0 in our brains. But we're saying by definition the 0 factorial is 1 because we need it for our formula. Okay? And when we start doing questions, this will make sense. If we take 0 objects and rearrange them, how many ways can you do that? Well, there's only one way to do it. You can't. Okay? It's kind of a weird thing to consider, but we'll use it for now. So type these in the calculator. 7 factorial. You should try these. Don't just copy them down. Actually go in the calculator. What is 3 factorial? It's going to be 6. What is 12 factorial? That's going to be a big number. Okay? And it's important for you to start getting used to your calculator. There's a few other things I'm going to ask you to do, and they will involve finding these buttons on the calculator, so make sure that you do that. Okay, this one is a big number. $479,001,600. Okay, negative 2 factorial. Well, if you try that in your calculator, go ahead and try it and put brackets around the negative 2. Okay, and if you put that in the calculator, what's going to happen? You're going to get error. It doesn't work because you can't have a negative number in factorial. So this is not possible. I think your calculator might say error or domain error or something like that. Okay. this doesn't work. Factorial only works for positive numbers. Okay, 0 factorial, we already know that's 1. 1 factorial is 1. Okay, now I want to show you a little trick for getting away without a calculator, because you don't need a calculator for this. Here's why. If you went 8 times 7 times 6, if you did that, it would become a very big number. But if we do this instead, and write 8 times 7 times, and instead of writing 6 times 5 times 4 times 3 times 2 times 1, I'm just going to write 6 factorial. And then I'm going to write 6 factorial on the bottom. Now what is 6 factorial divided by 6 factorial? It's 1. And what's this going to equal then? 56. Okay? Now again, you could have put that in a calculator. You could have done it that way, but I want you to learn this way because you're going to need it for questions like this. How can we simplify this? Well, looking back to this question here, what did I do? I took the bigger number and sort of reduced it a little bit. So I want you to keep this in mind. Which is bigger? Is the top bigger or the bottom? Well, obviously n plus 1 would be the bigger number, so I'm going to reduce that one. What is 1 less than n plus 1? N plus 1 take away 1, that's n. So put n. What's 1 less than n? That's n minus 1. And then I'm looking in the denominator. I'm going to stop there. And I get this. And I can reduce that, and I just get n times n plus 1. Okay, this is n squared plus n. All right, we'll use that quite often. Okay, example 4. A puzzle designer decides to scramble the letters in the word education. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many 9-letter permutations can be created? 9 factorial. That's 9 times 8 times 7 times 6. Much quicker than doing it and writing each one out. All right, we get 362,880. By the way, my advice to you is when we're doing questions like this, when you get to one, try it first and then listen to me do it. Okay, don't listen to me do it and then try it. Like right now, go ahead and do example 5, pause the video, and then come back. How many 6-letter permutations? This is just 6 factorial. Okay. All right, 720. Now, those are basic. We've kind of been doing those for 2 days. Let's talk about something where it gets a little bit different. If all the objects are not chosen, so we're going to be given some objects, but we're only going to use some of them. Okay? Here we have a formula. And this is actually a button on your calculator, NPR. This means n objects, take r of them, and permute. So for example, this means there's 5 objects. You're going to take only 3 of them, and then you're going to say, how many ways can I rearrange them? Okay? So there are several ways to do this. Okay? The first way is to say, let's do it this way. How many of those 5 objects could go in the first spot? I could put 5 of them. And then how many could go in the second spot? 4, and then 3. Okay, this is 60. That's one way to do it. Okay, we'll call that option 1. Option 2 is to use the calculator. We're going to look for this button on the calculator. It actually looks like this, NPR. Okay, and what you're going to do is you're going to put in the 5, then you're going to find this NPR button, and then you're going to put in 3, and then you're going to put in equals. Okay, it will give you the same answer. That's the third way to do it. The fourth way to do it is to actually use the formula. Sorry, the third way, not the fourth way. The third way. Okay, so if we have 5p3, this means 5 factorial over 5 minus 3 factorial. Okay, and you should be able to do all three methods. If you get the calculator, you use this method. If you don't get the calculator, we're going to use this method. Because what is 5 factorial over 2 factorial? This is 5 times 4 times 3 times 2 factorial over 2 factorial, which is back to what we did originally, 5 times 4 times 3. Okay, all three methods you should know how to do. So why don't you try the next couple? Use a calculator for one, use a formula for the second, use a calculator for the third. Okay, now 7p1 should make sense. If you take 7 objects but only use one of them at a time and rearrange it, how many ways can you rearrange? And if you take 6 objects and you only want none of them, okay, well, none of them. Well, let's take a look at the formula on this one. This would be 6 factorial over 6 minus 0 factorial, which is 6 factorial over 6 factorial, which is 1. There's only one way you can take none of them. Okay. Example 7. 8 students are competing in a 200-meter race. How many ways can the students finish first, second, and third? Well, kind of a funny question because we all know that we're not all the same speed. We don't all have the same chance of winning, right? Like if we had a race right now, we kind of in our heads would know some people are faster than others. But let's assume that everybody has an equal chance. Okay? There are 8 students. How many of them could finish first? 8. How many could finish second? 7. How many could finish third? 6. All right. What we're saying here is there are 8. Let's take a group of 3 and rearrange them all the different possible ways. These are the same. Okay. So let's try that. 8 times 336 ways. All right. A little bit more. 8 of 12 songs on your, what of the 12 songs on your favorite playlist, how many ways can you listen to 4 of them? So again, how many ways? Let's arrange it. If you take 4 songs and play them in different orders, that's what this question is looking for. 12 items. Take 4 at a time. How many ways can you rearrange them? Okay? Now, I see one of these questions pretty much every year on the exam. Solve each equation for n or for r. Well, you can't use a calculator here because you don't know what n is. So we're going to use the formula. N over n minus r. This is equal to 56. Okay? Now we can simplify this. Which one of these two is bigger? Is it n or n minus 2? Well, n. So I'm going to count down with this one, and there I get n minus 2. I can't emphasize that enough. Which one are you reducing? You're reducing the bigger one. That's a very common mistake. People start reducing the wrong one and they can't figure out why it doesn't seem to work. So I get n squared minus n equals 56. So n squared minus n minus 56 is 0. And this can be factored. N minus 8, n plus 7. So n is 8, n is negative 7. Well, let's quickly check our answers. Could we have 8p2? Yes. Could we have negative 7p2? No. So we're going to reject that answer. All right, last one. Same kind of question. There's a variable. Let's change it to the formula. So 5 factorial over 5 minus r factorial equals 20. Now this one's trickier. It's a little harder to see what's going on here because the r is in the wrong spot. Now what's bigger, 5 or 5 minus r? Well, 5's bigger. R, what could R be? Really, there's only very few possibilities it could be. It can't be bigger than 5. Okay, so there's only 6 possibilities. This is actually going to turn into a guess and check question. Okay, so let's simplify this a bit. 5 factorial is 120. Okay, and if I cross multiply, I get this. If I divide both sides by 20, I end up with 6 equals 5 minus r factorial. So now, let's do a little bit of guessing and checking. What's going to go in here? There's very limited choices. If I put a 0 in, 5 minus 0 is 5. What's 5 factorial? That's 120. No good. Okay, that means this is also no good because 5 minus 5 would give you 0. What's 0 factorial? That's 1. That's also no good. Okay, let's try 1. 5 minus 1 is 4. What's 4 factorial? That's 24. No, I want 6. That's no good. Let's try 5 minus 2. 5 minus 2 is 3 factorial. What's 3 factorial? 6. That one works. But here's an interesting thing. What's 5 minus 3? 2. 2 factorial. Oh, sorry. I'm thinking about something else. That one doesn't work. Neither does 4. So r is 2. Okay, and I don't like those questions. I'd hate guess and check, but that's really the only way we can do that one. Okay, let's give you some homework. Page 701, numbers 3 to 8, 10, 11, 12.